Assalamualaikum warahmatullahi wabarakatuh. My name is Hazim and I am with Fitri, and we would like to present to you about our mini project for computer-aided production management. So first of all is the project objectives. So in this project, we would like to integrate Part D, Machine D, and Source 3 into Lab Scenario 3. Next will be before in the Lab Scenario 3, we only use part A and part B to produce product C. But now we have added part D to the recipe as well. So finally, we would like to analyze the bottlenecks, the machine utilization, labor dependency using simulation from Delmia Quest. So before that, we have to make a theoretical calculation for cycle time and production rate for each machine. So to calculate cycle time, we are going to use the process time and also the total number of unit produced. So for example, in machine A, the process time is 80 seconds and the number of unit produced is 3 parts. So we uh, we we got 80 seconds divided by 3 and we have 26.67 seconds per part as a cycle time. So for production rate, we use total number of unit produced divided by the total time. So we have 3 divided by 80 and then times 3,600 seconds. This is because it is for 1 hour. So we convert 1 hour into seconds and we got 3,600. So now we have the independent production rate for machine A is the 135 parts per hour. And then we repeat for each machine and we got their individual cycle time and also their production rate. So after we have calculated the cycle time and production rate, we can identify the bottleneck for this project. So we have found that the assembly machine is the bottleneck for this project. That is because it has the lowest independent production rate of which is 21.82 units per hour only. So how would this affect other machine? And so the entire floor maximum performance will be strictly capped by the assembly machine, meaning that uh, other machine cannot continue their process uh, only after assembly machine have done the process. So next would be we are going to run the simulation. So for the simulation, we use Terminal Quest. We are gonna run it for 32,400 seconds, uh, meaning that for 9 hours. Okay. So we slow it down and we could see that the operator will take part from part A, part B, and part D and take it to the assembly machine. So the assembly machine will produce product C. So for the simulation, we also include shifts and breaks for the operator. And for the machine, we also have failures as well. So if we fast forward, and then the simulation will be over. So after we have run the simulation, we could actually use the results to compare for the theoretical one. So for the theoretical target, uh, we can calculate it by using the bottleneck of 21.82 unit per hour production rate, and then we times it by 8 hours because even though the shift is 9 hours, also have 1 hour of total breaks for the operator. So we only times it by 8, and then we got 174.56 units. But if you look at the actual simulation, uh, the, we only produce 126 units. So we can see that the system efficiency is 72.2%. However, we have the throughput loss of 27.8% drop because of the real world stochastic variables, uh, which, uh, which means that which means that uh, we for actual for the simulation, there is distance travel by operator which affect the number of unit produced, and this is not included in theoretical calculation. So from the results, we could see that for the theoretical target for machine A, it should produce 135 parts per hour. But for the simulation, we only produce 15.33, and there is a large difference, roughly negative 8.64 in variance. We could see that in the bar chart as well. There is a huge difference between actual and theoretical. So next, I would like to invite Ahmad Fitri for the next slides.
Assalamualaikum. My name is Muhammad Fitri. Thank you for my friend. Now I will continue the presentation. So I will talk about machine utilization analysis. For the machine utilization, the most higher is machine assembly. So that machine is the our bottleneck. Uh, bottleneck, and then the lowest is machine B. So next, for the labor, we can see the utilization. The highest utilization is operation 4 for the assembly machine. So when we compare this, the operation 4 is the highest than other. So machine for root cause and production gap. So the cost of production gap is the because of we need also take the about the machine breakdown, we need to calculate, and also we need to include the distance between station, the and the propagation delay. So for the human part, we need to consider and buffer conjunction. So for the buffer, we setting for the one buffer, the maximum is 10 part only. Okay, for recommendation, for optimization, first we can duplicate the line machine, but it take more lot cost. So maybe also we can rearrange layout. So for the layout, we can reduce the distance, and the operator distance travel for handler will be reduced. Uh, the, and third, buffer expansion. So for buffer, previous we use 10 mats per buffer, so we can uh, make the 20 the max, increase the buffer maximum part we can put. And also for labor, we can see the labor operation for need more time, so we need also the focus for that part, and we can order, we can training that person, or we can add more operation for helping. For conclusion, the simulation value is not same with the theoretical, but for this subject is for the benefit is because we can maximize the plant efficiency before physical installation, so we can we can plan before we take cost and make it real. That's all from we. Thank you.